Welcome everybody, I'm Lucian Fogoros, and today we're talking about extracting value from operations, leveraging the engineering data. And our guest is Mr. Greg Pata, the VP of Engineering or Strategy Engineering at Aveva. Welcome, Greg.
Hi, thanks. Nice to be here.
All right, so Greg, maybe elaborate a little bit on how this data-centric engineering can bridge the gap between engineering insights and operational excellence.
All right, well, I think the biggest thing that we see is normally when you're populating operational systems, you're having to scrape data off of all sorts of engineering records that have been created. So if you go back, traditionally how engineering projects have been done, you create a lot of deliverables, engineers sign them, stamp them, and we flatten them into PDF documents that then go into document control systems, and then somebody's got to go and kind of yellow off these things with a highlighter and then put them into operation systems and extract the information again. Mm-hmm. Our contention is that that's a step that actually really isn't required, because we've got a whole suite of tools that right from the outset you can create all of that data. In fact, you're creating all of that data as part of your normal engineering processes. So why not keep it and persist it as data and make it exactly the data that you're looking for in the operation system so it's available for handover. So we're really talking about an operationally ready handover system that you can hand over directly into those tools, so you're not having to go and try and find all that data, and it just becomes an easy, seamless transition.
Got it. Now, what specific benefits can a non-engineering client expect to gain from this approach?
Well, I think there's a ton. One is just purely ease of transition, right? Mm-hmm. The amount of effort that goes into going through and scraping all that data off, it's huge. It's the massive amounts of work. But the other part of it is consistency, mm-hmm. and validation of that data. I think what we find is typically when you're doing a data handover from an engineering project into operations, you can start to find that different information, you've got conflicting records that don't necessarily tell you one or the other. Now you got to figure out which ones are true, or you even just create errors as you're doing that translation.
Got it.
And one other bit just is that in some cases, if you don't think far enough ahead into the operations phase while you're doing your engineering project, you may not even get the data that you were needing to turn up all those operation systems, whether it's maintenance systems or PI system or whatever, any sort of tracking system.
Right, and I was going to double click on that exactly. It's like how you provide engineering data, and it's accessible, but how do you make sure it's useful?
Yeah. So there's been a really significant industry-wide movement around standardizing on what a good data handover should be. And it's turned into a standard called CFOS, the Capital Facilities Information Handover Spec. And that's come from a number of owner-operator in the industry. I think Shell and a few of the other super majors really saw this as a gap as they were trying to get their projects launched. And so it's become sort of an industry standards body that defines a data model of these are the things that we need to have depending on the type of equipment or the type of facility at handover to be able to push them into the systems we want. So we always use that as a starting point. So that gives you a reference to say this is what you need to actually include in your engineering phase to be able to hand it over to the people that are going to operate that plant.
Got it. Now, can you double click a little bit on some use case or success story where you've had data integration and significantly improved the operational efficiency or perhaps decision making? Any sort of quantitative numbers? Our audience would love to see those.
Yeah. So I mean, I'm trying to think of a few examples. We've got quite a few where people in that transition we've seen where we sometimes capture it as in cost per tag, in terms of how much data he had to go find and seek, and we saw that it went like almost 80% reduction in cost of going and scraping that data, and then just instead of just having it digitally and moving it into the system. So that's when I say you're saving a lot of money just going and finding that. But then you get that added consistency and everything like that. And then we have other clients who have right at the outset of their projects put one of these data standards in place, and they've been able to, through the project, audit and see how much of the data they're going to need in operations has been created during the engineering phase. And we call that even a progressive handover. So you're actually able to start populating operation systems before the plant's even built.
Right, and you reference tags, and I'm just my mind into the HMI systems where because every license was sold based on number of tags, or at least most of them. Yeah. Is that what you're referring to when you say
That's exactly, an equipment tag, an instrument tag, could be a soft tag, just a signal or something like that. Every single one of those things has a certain amount of information it needs to be able to be populated in an operation system.
Right. Now, I want to go a little bit onto this digital journey, right? And maybe share some additional example on maybe you've taken some smaller company on digitalization journey. Everybody's on a different stage of it, and if any success story, additional one that you may have around there.
There's quite a few. I'm not sure how many I'm allowed to mention by name in terms of companies, but we have...
Perhaps the industry would.
Yeah, in the industry, definitely in the oil and gas industry, we've seen a huge movement towards that digital, starting off with that spec. And in fact, that's the first thing that we recommend in almost all of our new deployments and some of the super majors we deal with. They've been very aggressively employing this thing so that it basically becomes almost a vendor data record requirement contractually for their service providers like EPCs and process vendors, whoever's building the components that are going to make up their facilities. And yeah, we've seen that with a number of projects where they've been able to actually audit how much of that data is being produced at any given time. And they're actually starting to use that as a way to gauge how done is the project. Instead of saying how many P&IDs have I got, it's like how much data do I have? It's a different way of thinking. And it really shows a lot of efficiency as well in how they're able to manage, how do they keep their vendors on top of their service providers and their vendors that need to give them that information as well.
Got it, thank you for that. And now, we've talked a little bit about the data, but also this concept of digital twins is getting traction in various industries. You've referenced a little bit to oil and gas, but perhaps expand a little bit on how Aveva Engineering Solutions contribute to the development and maintenance of digital twins, and so perhaps what role does it play in increasing the efficiency of and predictability of the engineering projects?
Yeah, so yeah, for sure the biggest thing is when we're doing data-centric engineering, you have to think of some of the workflows that you typically go through as sort of what I would call in the traditional document-centric workflow. And I always look at the creation of a P&ID as sort of, that's a core thing, regardless of whether you're in CPG or oil and gas or whatever. You need your core documentation around a P&ID. And if you look at what are the sort of artifacts that come out of that is, you would normally have somebody create a P&ID or a set of P&IDs, and until they got to a certain state of maturity, those wouldn't be released for anybody else to use. So first of all, you got a schedule delay there. And then second, once they're released, somebody's got to go through that and say, create a valve list, or an equipment list, or an instrument index, and so all of those things become now artifacts that come out of this P&ID. So in a true data-centric environment, as that P&ID is being created, all of those lists are automatically being generated because it's just another way of viewing the same information. It's just in a tabular form instead of on a schematic. And that sort of efficiency is massive. And it's also really important in terms of quality control and consistency of that data. So as you move data from that P&ID to all of these other artifacts through the old way of, again, sort of yellowing off and making these lists, there's a chance that you're going to get that data wrong. In this, in data-centric, the data just gets put in one spot and it's viewed in all sorts of different contexts depending on who the consumer is and what makes sense to them. So if you're a mechanical engineer, you'll see it in the form of a data sheet. If you're an instrument guy, you can see it as, in terms of an instrument index or something like that. So, but it's still essentially the same data. You're not moving it around.
Right. Now, your session this week at Aveva World is focusing on making the job easier for non-engineering clients, letting them focus on what they do the best. Perhaps it's their other processes, but perhaps not engineering.
Yeah.
Anything you want to add towards that? What should people expect there?
Yeah. So what I'm really hoping to convey is, there's, if you start with that demand of a digital project right from the outset, you get all of these advantages in terms of getting the data handed over to you as part of operating the plant. But then you have a great advantage is when you're actually operating it, now you've got a real archive or real representation of what that facility was engineered to do in the first place. So in a lot of cases when you get to a digital twin, there's a lot of examples where people have really good operations information. They know when something's been maintained, they know how frequently it should be maintained, and then they could go to their performance information, they could see how well it's producing stuff. But they don't really correlate that back to what was it meant to do in the first place. So by having that data-centric engineering information readily available, you can now compare how is it operating versus how it was supposed to operate when it was originally designed. I think it's quite frequently you're going to find that you're either potentially not running the plant as hard as it could be, so maybe you've got production that you could have that you're not trying to get, or it could be the other way around where you're actually didn't even know it, but you're running your plant too hard and you're creating a maintenance nightmare you just don't know when it's going to happen, and you maybe need to maintain it more frequently. So when you start to put all of that data together as part of a digital twin story, suddenly that digital, how it was engineered view of the world becomes incredibly important for making decisions around when are you going to maintain it, are you actually pushing the facility to the maximum capacity that you can responsibly, right? So it's just suddenly your decision-making capability goes way up.
Thanks for sharing the insights, and if you're in the audience and you have additional questions, feel free to leverage the hashtag you see on the screen, Aveva World or IIoT World, and we'll make sure we're tagging the appropriate folks to get your answers, and you can also view us online for additional session on the topic and many others.
Yeah, perfect. Thanks very much.